record. Okay, cool. So, Puerto Rico, awesome, Fabiola. That's really neat. Okay, so this is the first lesson of this unit, and we're going to go to new heights with this sort of thinking, and I'm excited to share sort of my philosophy with you, which takes in a lot of different perspectives and different elements, and it's global. I bring in a lot of examples from around the world, which you'll see today. So a couple of things to know about me. You can call me Ms. Cat. My name is Holly Catherine Lammert. That's my full name. Which, if you're a science nerd, you might know what HCl is. Anybody?
Does it involve the periodic table of elements?
It does, yeah. H is hydrogen and Cl is chloride. And so hydrogen chloride is actually a really super acidic compound.
Hydrochloric acid.
Hydrochloric acid,
My favorite element is beryllium.
Ooh, awesome. What do you know about beryllium?
Nothing really. I just read about it in a book a little, and it seems interesting.
Oh, cool. Well, we'll learn a little bit more about that today and how we actually came to understand what all the elements are.
What did you say HCl meant?
My favorite element is probably either gold or silver.
Ooh, awesome.
Very common, but they stand out to me.
Yeah, totally.
What I like is hydrogen that makes stars.
Yeah, and we're gonna talk a little bit about that today too. We're gonna go all over the galaxy to learn something new and hopefully open your minds and have you see from a different perspective. So, are you guys ready to get started?
Yeah.
Yeah? Should we dive right in?
Yeah.
Yeah, okay, awesome. So throughout this lesson, today is like an introduction, but if you stay with me through this, we're gonna take experiences, we're gonna do engineering challenges, we're going to experiment, go on adventures, collaborate together, talk about how we can change the world and how we understand the world so that we can tackle challenges and create solutions to create a future that you guys are really proud to live in. Does that sound good?
Yeah.
Sweet. Okay, so we're going to start with this question. How do we know what we know? So use the raised hand option if you're like, okay, how do I do a science experiment? I know how to make a hypothesis. Yeah, you guys raising your hands. So a hypothesis, you might have heard as something like an educated guess, right? But if we dive in a little bit deeper, we can see that a guess is defined as an opinion that one reaches or to which one commits oneself on the basis of probability alone or in the absence of any evidence whatsoever. And so when we're doing science, and we'll talk a little bit more about what science is in a minute, we can make a hypothesis as to what we think is going to happen. And it can be a guess, but oftentimes it's a little bit more than that. And that's why we call it an educated guess. We use previous information to help us understand our world. And sometimes the things that we are trying to understand are extraordinary claims. And does anyone know who this person is? This is
Albert Einstein?
Nope.
I do not.
But we'll talk about him in a minute. This
Steve
is
Ruth Goldsberg?
Nope. This is Carl Sagan. Has anyone ever heard of him?
No.
No. Okay. So he is a big thinker in the world of science and philosophy and understanding our universe. And he actually, we're not going to talk about dragons today because I didn't include it in this PowerPoint, but we could if you come back for more lessons. We can talk about, whether or not dragons existed. That can totally fall within science, even though a lot of people think it's more like folk legends or it's like a cultural thing. But his claim here is the pervasiveness of dragon myths and folk legends of many cultures is probably no accident. So he's making this connection between whether or not there are dragons, this mythology, and finding actually dinosaur fossils. Okay, that's a little bit of a side note because we're not going to get into that, but who has seen this symbol before?
Infinity.
Yeah, this is the infinity symbol. So it's used in math if you want to talk about numbers that just keep going and going and going. And the awesome thing is as we go around this infinity symbol, it goes from one side to the other side. So I like to think about the infinity symbol and think about the difference between science and something like spirituality. So I believe in the next slide, I'm going to ask you guys if you have a religion, if that's important to you, because I'm excited to know that. But first here, we're going to just talk about, oh wait, it's on the slide. Yeah, so if you're on the Pear Deck, you can go ahead and answer this. You can see what kind of religion are you? You're not religious, or Catholic, Christian, Muslim, Buddhist, Jewish, direct as Islam, or other. And if you're other, go ahead and type in the chat box. I just chose some of the more popular religions, but I could have kept making more.
It kicked me out of it.
Oh, it did? You can go ahead and log back in if you go to join PD, and then the code is right up here, EKINKY.
Okay.
Cool. Okay, so there's lots of different ways we know what we know. And so here, I define science as a logical way of knowing about the world that uses evidence from experimentation and observations to make claims. Does that seem good with everyone? Anything to add about what science is?
No.
A very fun subject.
Yeah, it's a super fun subject.
Not just a subject, it can be a hobby too.
Yeah, totally. It can be a hobby, be something you do for fun. I participated in an adult science fair recently, which was like my hobby, and that was super fun to do.
I don't need anymore.
What's that?
I don't need the code anymore.
Okay. How many people here have participated in a science fair? Go ahead and raise your hand. Couple people? Awesome. Super cool. Okay, so then there's another way.
I did one about plastic and how plastic affects our world and
Oh, that's so cool.
plastic. Yeah, and then I also made like toys with like recyclable materials.
No way.
To
That's
show,
awesome.
yeah, to show that, there's another way of not using plastic.
Yeah, that's really cool. You'll be excited. We'll talk in a minute about the Google Science Fair winner from last year. He did his experiment on plastic, which is kind of neat. Okay, so the other side of this is a way of knowing is spirituality. So for those of you that have a religion, you might use your spirituality to be an intuitive way of knowing that uses faith, some sort of clarity that you achieve by your beliefs and trust in that system. So I use this and I like to talk about these two different ways of knowing and how we can use them together to know and understand our world. And then I think this is kind of interesting. This is a quote from one of my favorite scientists who made, well, I'll get to this in a minute, I guess. Here's my next little animation. When these two things cross, we can have a connection here right in the middle. So a lot of times in our world right now, we have people who are not able to have conversations with each other. And what I want you to see here is sometimes when we can see across the aisle and we can each see what the other one's thinking and just listen to each other, oftentimes we're able to come to a better conclusion. And that's what this one scientist said. She said, "We scientists feel so sure of ourselves because we have data to back it up. It's sometimes hard to listen." And this scientist actually made this Barbie, which I think is really cool. This is a tree climbing Barbie. And she did that because she studies the canopies on top of trees. And she thought that there was not a lot of girls who felt encouraged to be able to study that kind of thing. And so she made this Barbie in order to encourage girls to do that. I think it's really neat. Okay, so when I say the word elements, you guys have already started to share some of your favorite elements. And a lot of those come from this thing. What's this thing called?
The periodic table of elements chart.
Awesome. Yeah, that's exactly what this is. So if you choose one of the, I want you to take a close look and maybe type in the chat bar one of these elements that you find interesting and where it came from or what it's used in. Just to give you a minute to look at this.
What did you say we do?
So take a look at this really cool periodic table chart and take a look at one of the elements and choose it, and then write in the chat box what it's also used in. So for example, I might say, I didn't know that we had phosphorus in our bones. So I'm gonna do that.
What if I don't know like what something it's in, like in something else?
Just using from the data, from the graph that we have up on the screen, the data chart.
Okay.
Oops. Yeah, nitrogens and proteins. So there's lots of, all of the proteins that build up our body need nitrogen in them. So there are plants that take nitrogen from the air, which we'll talk about in a minute too. And they take the nitrogen from the air, put it in the plants, then we eat the plants, and that's how we get nitrogen. Or we might eat animals that had eaten the plants, and that's how they get nitrogen. Yep, Avery, so pick a picture and say what the picture says. Yeah, egg yolks have sulfur in them, exactly. So when you think of, when you smell something that's kind of that eggy smell, you might think, oh, there might be some sulfur in that. Another cool thing about sulfur is that deep in the bottom of the ocean, there's these things called hydrothermal vents, which are really hot, sulfury plumes of spewing gas that comes out of the earth. And down there we find these really neat worms, tube worms that actually live and breathe using the sulfur. So can you imagine breathing with like rotten egg smell? That's basically how they live. Awesome, thanks Prisha, that's cool. I do really like the periodic table song. And yeah, mercury is in thermometers, that's awesome. Okay, so we came up with the periodic table of the elements. It was actually someone, his name is Dmitry Mendeleev. Has anyone heard of Mendeleev? Maybe not. He was
I have read a book about him.
Oh, so cool. That's awesome. So you might know this story then. He grew up in Siberia, and when he was there, he had a kind of a hard life. So his dad had left, so it was just his mom who was raising him, and she would go to work every day at a glass blowing factory. And when he was maybe kind of the age of all of you, like younger, a teenager, the glass factory actually burned down, and him and his mom went on a big long journey so that they could go to the nearby city so he could continue to learn. And he became really obsessed with organizing how our world works and looking at all these different things that he eventually called elements. And that's how we get the periodic table of the elements. Now, why do we call it the periodic table? Yeah, Daniel, he also had some math theories. He was a pretty big thinker. So the question is, can anyone think of why we call it the periodic table? What does that word mean, periodic? Like if I brush my teeth periodically, what would that mean? Yeah, go ahead, Smiti.
I think call it table
Oh,
because it's a repetition. Like,
yeah.
do it twice. Oh, it might be like a way of organizing things. Like he's obsessed with organizing things, so this may be like why he called it the periodic table.
Yeah. So it's an organization based on how they occur in how they show up time after time after time. So we might have periods in history, and that's like one period and then another period and another period. Or you might say you periodically brush your teeth, which means you do it every single night. So what he found is that there is a trend that from neon and argon and krypton and xenon, they all have the same characteristics or qualities. And so all of these happen to be gases. And he found that the atomic number increased, and he was able to then organize them in these rows and columns to match the numbers. Okay, so this is kind of a funny cartoon. And we'll talk a little bit, so this curriculum is called Elements of Change. And so we'll talk about how you can change elements. You can go from one element to the next element, but you have to change something really important. Does anybody know where my chemistry expert's at? How do you get from one element to the next? Smriti, what do you think?
You add more atoms.
So if we take an atom is actually like if I had one whole atom of, let's say, gold. Okay, so, or let's use silver. Okay, so silver is right here, and its atomic number is 47. And what that means is it actually has 47 protons in its nucleus. So if I want to get from silver to cadmium, I would add one proton to the nucleus. And that's how you get from one to the next. So here this cartoon's kind of funny because he didn't quite know about atomic numbers, but he still was able to put these elements in their places here. And he did this by having all these different cards that he would line up, and he would place the numbers on them with the atomic weights to be able to arrange all of these elements the way that they're arranged here. Okay, so I want to give you a couple other methods of understanding the elements. So how many people, where are my Avatar fans at? Raise your hand.
Me, definitely me. Me and my brother are big Avatar fans.
Wait, who said that?
I did.
Oh, Avery, awesome, cool.
Me,
So
Morgan and Patrick were watching it today, actually.
no way, that's awesome. Well, I'm glad you're gonna learn a little bit more about the elements then from a sciencey point of view. But if you were to be in which clan, which clan would you be in? What do you think, Avery?
Patrick said I should be a waterbender because I have blue eyes, brown hair, and tan skin. I mean, it doesn't look like it right now, but my skin is tanner than all of my family's. Except for my grandma's.
Would you guys all be in different clans?
I would probably be in either water or earth.
Awesome.
I took a test screen.
I'm actually water by like what I've learned.
I took a test thing that said I did like a little thing where I said what element can I bend, and it said I was the Avatar, but I said what like like Todd saying I was one in, and it said Air Nomads.
Oh,
It said I was the avatar too.
oh, that's awesome. Yeah, and what makes the avatar special to teach everybody else, maybe if they don't know?
He can bend all 4 elements.
Yeah,
They
you can be a master of the elements. And so if you follow me along through all these lessons, that's what I'm hoping that you guys understand. You can be a master of all these different elements. And we're going to take a look at a couple different aspects of thinking about the world, not in terms of the periodic table, but we are dealing with science. But we're going to just play with it, and we're going to talk about fire, air, earth, water. And that's how we're going to learn a little bit more. So there is also an ancient science, which is called Ayurveda, and they also talk about the elements, but my slideshow here isn't quite set up there. Okay, so anybody know who this is? It just says on the bottom, but otherwise I would never expect you to know this. But this guy's name is Empedocles. Oh my gosh, I knew I wouldn't be able to say this. Empedocles. Empedocles. Okay. Anyway, and he is known for being the first person to really talk about these different elements. And this is his quote from him. Now hear the fourfold roots of everything, enlivening Hera, Hades, shining Zeus, and Nestus, moistening moral springs with tears. And so this is what he described as air, earth, water, and fire. Anyone know who this guy is? This is Plato. And Plato also had a theory of elements. And what he said in his form theory is that he described elements in the physical world, which we can observe with our senses. And he said those are constantly changing. And that he said that there's these unseen forms of the world which were unchangeable. And he's actually the first person that we credit with calling these things elements. And he actually, this is kind of cool math connection. He thought each one of the elements should have a geometric shape. So guess what the element to the left is?
I think I know how you pronounce that.
Oh yeah, go for it.
Hold on. Can you hear it?
Say it one more time.
Empedocles.
Empedocles. Thank you for that. That's awesome and helpful. Okay, so yeah, what do you think this element is over here?
Air.
This one's air, the tetrahedron. This cube is earth. This one in the middle is an octahedron, water. And then this one is
Fire.
fire. Cool. And this last one he described as the heavens, which I think is interesting. Okay, so breaking this down, elements of change, and we're going to talk about this tiny 2-letter word for a minute. And this 2-letter word of, if you look up the definition, is expressing the relationship between the part and a whole, which I think is pretty profound. You might also call it expressing the relationship between a scale or measure and a value. So here we go. I told you we talk about this guy. Who is this?
Albert Einstein.
Albert Einstein.
Totally.
Albert Einstein.
And so he talked about this part and whole kind of thing. And what he said, which I can't, dang it. Here we go. Let me just bring up this. I knew I was going to mess one of these up because it's kind of hard to do all these things. Give me a minute. Okay. So this is what he said. If I bring this forward. Okay, he said, a human being is part of the whole, called by us universe, a part limited in time and space. He experiences himself, his thoughts and feelings, as something separate from the rest, a kind of optical delusion of his consciousness. What does that mean to all of you? That's kind of a deep thought here. Yeah, go ahead. Go ahead, Smriti.
I think that it means that he's thinking that a lot of us, we express our thoughts and feelings. So I think that optical delusion of consciousness means that like you're very concentrated.
Uh-huh.
And I think he's trying to explain that everyone's feelings is kind of like that. It's what they are and they're feeling at that moment of time.
Yeah, awesome. I like that interpretation. Does anyone have another idea? Okay. So, okay, super cool. So this of, sorry, I'm just trying to figure out what's going on here. Why I can't see my screen. Where's my PowerPoint at? Here we go.
My computer lags like that all the time.
Oh yeah, I know. It's sometimes when you try to do a lot, it's just like too much. Okay, here we go. No, okay, yes, here we are. Okay, so I want you to think of what's your of. Like, what are you part of a whole of? Can anyone think of what that might mean? For example, I am one part of the whole school that I teach in. And so I'm a teacher in my school. Can you think of that for yourself? And I didn't make a question for this, but maybe if you want to type in the chat box. What are you one part of? Yeah, totally. You're one part of your family. That's probably true for all of you. Anyone have another idea of this? What's your of? You're a citizen of the United States. You're part of a class. How are you one part of a whole, of a bigger picture? Yeah, like right now. Totally. One part of a family. Awesome, Daniel. Part of the world. Yeah, like you're one part of 7 billion people that live on this planet all together with us. And the one world is one part of the whole universe, which is pretty crazy. And yeah, good, Avery, you're one part of your group of friends. So I'm gonna, yeah, thanks, so young, part of people's lives, part of the universe. And I want you to start thinking about like, who is your community? Who are you part of? Like, if you were to define, some of you who said you were Christian, maybe that's your church. How many people are, raise your hand if you're actually in school right now or if you're doing virtual school. A couple people are actually in school.
I'm doing virtual school.
What's that? So virtual yeah, it makes it a little bit harder right now to figure out what part of the school are you, because sometimes you don't get to see your classmates as much, which makes it hard, even though it's kind of fun when you're able to come together in these classes on Zoom. Okay, and we just talked about what role we play in it. Okay, so elements, we got that down. Of, we got that down. Let's talk about change, elements of change. So one of the biggest examples of change is the seasons. So do you guys know what was yesterday? What holiday or what special occasion happened yesterday?
Start
Yes,
of
we celebrated. What did you have? What did you say, Prisha?
Start of fall.
Yeah, it
It's
was
the start of fall.
totally. It was the fall equinox, which is a change in season. So I want to just tell you about a couple different ways that we celebrate the seasons. And seasons as, oh, cool, awesome that you decorated your house. We might start to put things like pumpkins out, or I don't know what all things you guys do for fall, but this is one of my favorite times of the
It
year.
still doesn't feel like fall though. It still feels like summer.
It does. Yeah. And right now we're seeing a little bit of a change in the seasons, and what was normally the defined limits of the seasons are getting a little bit pushed, right? So we have longer summers and shorter winters right now, because of another thing that's changing, which is our climate. Okay, so to talk, just really, I thought this would be kind of fun, but here's a couple examples of ways that we celebrate the different seasons. So in India, they have a light festival where they celebrate that the light has won over darkness, and it's called Diwali. In summertime, or in springtime, I think I have these, yeah, that's springtime. In Thailand, there's something called the Songkran Water Festival, where they have big water fights in the streets. This is close to my hometown in Wisconsin, and they have an ice sculpting festival. And then I thought this was kind of fun, but random. In Korea, they have the Boryung Mud Festival, which actually was created in 1997 to support and promote a type of makeup that was made with mud, which apparently has some useful minerals in it. So I thought that was kind of interesting. So go ahead and say, what is your favorite season and why? That's the little question you can answer in the Pear Deck. Or wait, no, I didn't do a Pear Deck for it. Anyway, yeah, you can type it into the chat box if you want to say what your favorite season is. So all things change, right? And this is another universal law that everything is going to change at some point. So I want you to think a little bit about how you are different than you were a year ago. You guys are changing dramatically because you're all adolescent, right? Like you're growing. And then even think to like a minute ago, you were a different person. And a week ago, you had different cells on your skin, right? We've shed our skin and constantly regrow. This is a principle also in Buddhism, and this is the Buddha. This is Siddhartha Gautama, who achieved what they called enlightenment because he sat underneath a tree, and he sat there for a really, really long time without moving. And when he did that, he was able to really see what the world was all about. And one of those things that he came to a conclusion about was that everything changes. That's all it is. And he called this principle anicca, the universal law of impermanence, that everything's going to change. Happy birthday, Morgan, early. So we can see this when we talk about energy. So let's talk about another really significant scientist and philosopher. Anyone know who this is?
Newton?
Yeah, this is Sir Isaac Newton. And he thought a lot about the world. He was actually, I don't know if people know all the stories about Newton, but when the bubonic plague hit, he locked himself in a closet, just like a lot of us are doing. And he had some of his most profound ideas when he was just sitting there like in his closet. So if that gives you any hope to why quarantine might be an okay thing, you can cite Sir Isaac Newton. But he thought about all these crazy things like matter, place, time, motion, the cosmic order, and light, color, and vision. He actually did some really crazy experiments on himself where he took a needle, put it behind his eye. Don't try this at home. Put the needle behind his eye and then moved it around to change the shape of his eye to see how that would affect how he could see things, which is just, when you think about it, really bizarre. But how many raise your hand if you wear contacts? That's basically what's happening with a contact. It's changing the lens and the shape of the lens from convex to concave so you can see better. Okay, so we can see energy change when we think about potential and kinetic energy. So if you have a balloon, you can do this, and you blow up the balloon, and you're adding energy to the balloon, and then as you release it, all that air gets released as kinetic energy. So we see that in the law of thermodynamics, matter cannot be created nor destroyed, and neither can energy. So energy just changes form. So let's talk a little bit more about this. How is energy in transition? So I want you to enter, this is kind of a fun thing to think about, how you're feeling right now and your last thing you ate. So for example, I'm feeling excited and the last thing I ate is a brownie. So my alter ego is I'm an excited brownie. So go ahead and type that in the chat box, what you are, how you're feeling right now, and the last food that you ate. David's an excited corn dog. Morgan's happy chips and salsa. Hoyoung's happy ice cream. Pretty fun. Tired Scooby snacks. That's awesome. Okay, cool. So every time you eat something called complex carbohydrates or complex macromolecules. One of those is a carbohydrate. You might also eat something called protein, lipids, which are fats, or nucleic acids, which is basically DNA. So anything that was once alive has nucleic acids in it. Curious cookies, that's awesome. So as we eat, we actually burn the food. It's a fire, it's a chemical reaction that releases energy in the form of heat, which keeps us warm-blooded, and kinetic energy. So I can move around here because I've eaten food today. If I didn't eat any food, I would eventually wither away and die. You guys know this feeling when you haven't eaten in so long and you're like, I'm so tired, I can't do anything. Yeah. Okay, so I want to take a minute and talk about how energy has changed with this really neat thing called a PhET sim. Has anyone ever used a PhET sim? Refied. Okay, let me find the one that I want. Change in energy. Okay, so, oops, what happens here? Crunchyroll with eel sauce. You guys are making me hungry. Okay, so what do you think's gonna happen if I pull on this lever? And I'll show you.
The water will fall.
Yeah. So now I'm starting a waterfall, and this is called potential energy turning into kinetic energy, which is turning into mechanical energy, which is moving this wheel, which is heating up this hot plate, which causes the water to boil. So do you notice how the energy just changes? And now we can see it. So everybody reach in your back pocket, and I want you to grab out your molecule goggles. So believe it or not, you have them back there. If you have glasses on, maybe they're already there. But when you put your glasses on, you can actually see what's happening down at this level. So here we have mechanical, electrical, thermal, light, and chemical. So if I pull this lever, then I have what kind of energy is coming out of this pipe?
Mechanical.
Awesome. And when the wheel churns, what is it changed into?
Mechanical.
Mechanical. And then it goes through this wire, which is probably copper. And what kind of energy is in the wire?
Electrical.
And what kind of energy is in the water?
Thermal.
Thermal. So what do you think happens if I were to replace this water with a light bulb? What's going to be the type of energy here? A little bit of thermal, and eventually gets
Light.
released as light. What do you think will happen if I, instead of using the falling water, if I use sun? What do you think I need to put here to transfer the energy from the sun to the light bulb?
Solar panel.
Totally. If I were to change this incandescent light bulb to a pretty efficient light bulb, what would happen here? Do you think there would be any thermal energy produced?
No.
No, and that's why we use LEDs sometimes. They're a lot more efficient in just producing light instead of heat. Sometimes there's a little bit of heat. Okay, what kind of energy is this? I'm going to go back to the wheel. If I heat up my teapot, that water that was moving down before, now the water is moving up, and that's electrical energy. Or no, I'm sorry, mechanical. Do you get how this works?
Yeah.
Here's, if you had a bike, you could hook up a bike, and as she starts pedaling, what type of energy is she using inside her body?
Mechanical.
Chemical. That's like when you break down your food. You're eating, I mean, I don't mean to like ruin food for you guys, but like you're eating chemicals, right? Anything can be described as a chemical. It's not like a toxic chemical or anything, but what happens when she ran out of chemicals to burn? What do I need to do?
She can't bike anymore.
Yeah, so we need to feed her, then she gets more energy, and then she can bike again.
It's like when you like eat and then you go running, then you burn all your calories that you ate.
Mm-hmm.
Just like that. And sweat is like
totally.
a way to prove that.
Mm-hmm. Okay, so how do we generate energy then
Why
in
is
our
she
world?
on an empty stomach?
Mm-hmm. That's kind of hard, huh? So we know that the Earth spins. I think it's kind of interesting to know the sun spins as well, just in case you didn't know that. But all the energy that we have on the Earth comes from the sun at some point. So how do you guys charge your phones?
Electricity.
Yeah, how do we get that electricity? I'll tell you. So we can get it from solar, Let's follow the path of the sun and see how we can charge our phones from that. So if I take this sun and it goes to a plant, what kind of reaction, someone probably knows this reaction, that takes the sunlight's energy and changes it into sugars within the plant?
Photosynthesis.
Yeah, so there we have our chemical reaction that's taking that energy. And then imagine that happened long ago in what's called the Carboniferous period, where there was lots of carbon that was formed. So the sun comes in, it hits the plant, it takes in carbon dioxide from the air, and then it turns it into plant matter, and then that plant matter dies, and it gets buried along with dinosaur bones and all these things, and it becomes this. What is this?
Gas.
Gas. Yeah, have you guys ever heard gas called fossil fuels?
Yes.
Yeah, and that's where that name comes from. So long, long ago in this period where there was dinosaurs roaming the earth, lots of that plant matter got crushed down underneath, pressurized, heated, and turned into oil. And that's where we get fossil fuels or oil. So all things that generate energy that would be turned into electricity, at some point turn a turbine around a magnet, which generates a current of electricity. And so we can do that with wind too. If we have wind turn a turbine and there's a magnet in there, that converts it to electricity. Or like we saw with the wheel, if we turn a wheel, that rotates around a magnet, which generates electricity. Okay, so we just talked a lot about energy, which is different than matter. So why does this all matter? What would you guys describe as matter? And this is something that you can use called a Freire model. So you can write the definition of something, talk about its characteristics, give examples, and then non-examples. So when I hit my desk, I'm hitting something that's made out of matter. And it's made out of tons of different little atoms. My pen is made out of matter. My glasses are made out of matter. So go ahead and write in the Pear Deck an example of matter. What are things that are made out of matter? Awesome. Yeah, your computer. Mm-hmm. Yeah, you are made of matter.
When I went to virtual school, like today morning, my classmates were made out of matter.
Mm-hmm. Awesome. Very good. Yep, all those things, Avery, are made of matter. Anything that's like physical in the physical world. Let me give you some examples of things that are not matter then, and maybe that'll help you understand. Scooby snacks, totally, those are made of matter. Mm-hmm. Things that are not matter are things like dreams, magnetism, radio, concepts like love.
Are words
other things that are not matter? Go ahead, type that in the chat box. So now, type in the chat box things that are not matter. Yeah, sounds like words, language. Mm-hmm. Thoughts. Mm-hmm. And air is actually, if we could talk like the negative space within air, it's not. But if you have your molecule goggles on where you can see molecules, you can actually see that the air, and we'll talk about this in a minute, is made up of matter. Yeah, and Hoyoung, awesome. Gravity is just a concept. It's not necessarily a thing. Air from a heater of a fan. If you're talking about the heat, that's energy, and that's not necessarily matter. Mm-hmm. When does this, okay, it's 6 o'clock. We're liking it, so you want to keep going? We can go just a little,
Yeah.
We'll go, I'm on slide 13 of 39. So go ahead, and if you
Yeah,
need
I'm
to log
fine.
off
I
'cause
love.
you're done, you can do that, but otherwise we'll just, we'll keep going. Does that sound good to everyone?
Yes.
Okay, cool. I think we're gonna learn a lot, so stick with it and it will be fun. All right, here we go. But what matters to you? So we just talked about matter. I want to tell you guys about this word called, I just learned this word this week and I love it. Solipsism. 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 It's a theory holding that the self can know nothing but its own modifications, that the self is the only thing that exists. And you might call this like severe egocentrism. Like you're the center of your own universe. Have you guys ever heard that? Which is kind of a cool thing to think about. Like you are the center of your own universe. You're not the center of the universe, as there may not be such a center. Because our universe is just expanding in all directions. So 13.8 billion years ago, what happened?
The Big Bang Theory?
Mm-hmm. Yeah, and we call it the Big Bang because lots of different elements were born out of this one event where everything kind of collapsed on each other and then expanded. And so you might also call this thing the Great Expanding, but they call it the Big Bang because it sounds cooler. But I have heard some scientists be like, it's actually more accurate to call it the Great Expanse or the Great Expanding. So our universe is expanding. You are the center of your universe. So what's the most important thing in your universe? That's what I want you to respond under the Pear Deck. What is the most important thing to you in your own universe? Oh, let me guess who wrote that, Avery. You do love your Scooby snacks. I'm really wanting some Scooby snacks now. Haven't ever thought about them in a long time. Doritos! Everything that is a fact. I'm so excited to see what the rest of that is. Everything that is a fact is at the center of your universe. Okay, cool. That makes sense. Cheetos! You guys all must be pretty hungry. Anybody else want to get in there? Family? Totally. Traveling? Awesome. Your bed and your blanket. That's very nice. Teachers? Awesome. Food. Cheez-Its. Legos! Cool. I haven't played with Legos in a while. That'd be fun. Okay, so that kind of sums up. Let me tell you where we've been so far. We talked about all the elements and where they came from and different ways to look at matter and divide it up into fire, air, earth, water. We talked about how we're part of a whole, how you're part of a community. We talked about how everything changes. This is basically a universal law of the world. We can look at that from seasons, from the fact that you guys are all growing, from changes in matter and changes in energy. So are you ready to dive into the elements? Talk a little bit about each one, earth, wind, water, fire.
Wait, when are we done?
We're gonna go, this will probably go till about 6:30. Does that work for everybody?
I'm good to go.
You have to go?
Yeah.
Okay, well,
No,
you know what?
I want to see.
Let's wrap it up here. I'll just click through some things. Fire, earth. I want to talk about this wonderful woman who lived in a tree for 2 years. I want to talk about
Actually,
pandas.
can we go till 6:30?
Well, no, I do actually kind of want to wrap this up anyway, but because I'll run another lesson that'll go through each one of these elements. So I'm just going to fly through them really quick and give you some cool examples. Pandos is the largest organism. So when we talk about, wait, what element I was just on? Earth. Yeah, part of the earth is this, all the organisms that live here. The soil, if you look down into the soil, you can see that there's really cool stuff called cryptobiotic soil. And Daniel, that was the person saving the redwoods. Yep, this Julia oops. My computer is like, stop, we're done. Oh. Okay, cool. Whew, that was stressful. Exactly, Daniel. They were camping in the redwood trees so that people wouldn't cut it down. Morgan, we talked about pandos, which means I spread, and it's a type of aspen tree. Pandas are also really cool and should be protected. I agree. When we talk about air, air is actually made up of 97% nitrogen, that element we were talking about that's in protein. When you put your molecule goggles on, they might look cute like these little froggies or like science goggles, or they can look like glasses, or they can be completely imaginary. But what they allow you to do is actually see into the air, which is made up of all these little molecules. And sometimes those molecules, like plastics, can actually get into your system. And so in Utah here, we have really bad air quality. And so sometimes we talk about things like PM 10 and PM 2.5. And these are actually little particles that can get into your body. So for example, when you open a bag of Cheetos, you release about 14,000 microparticles of plastic into the air, which is just kind of insane. The PM 2.5 is an example of how big something is. So this is called particulate matter at 2.5 micrometers. So when we look at the scale, it's really, really tiny. You can fit 40 of these across one piece of human hair. Other things you might think of when we think of the air is how to harness the wind. So I looked up recently, this is kind of cool. This Zephyrs model is a type of micro turbine that you can put in your backpack. And so you could be generating energy and charging your phone from there. This is a really cool type of turbine that's very able to harness the power of the wind when it's in hurricane force fast winds. And then this is a neat idea that no one's done before, but it's called the windstock idea. And basically you would put a pole up into the air that would be really flexible. And as it moves, the movement allows us to generate electricity from that. So really cool things in terms of harnessing the wind. This is one of my favorite movies. And if you join us for the air lesson, we'll dive way into this and talk about this example of a boy who in Africa for his village actually pulled up water from the ground using a windmill that he built. So as he turned the windmill, he had that sit on a magnet, turn a turbine, generate electricity that used a pump to pull water up from the ground. And that allowed him to water the fields, and he saved his whole village, which is really, really cool. Oh, and cool, David, you read the book. Smriti, I will email you the next class. I will probably have it for next week, Wednesday, again. And we'll go into the first element.
Okay.
Mm-hmm. So yeah, I just talked about if you're in LA or if you're in Salt Lake or if you're any big city, there's lots of air pollution. And then I think this is really crazy. We can actually go up into the air and make our own weather. So we can put silver iodine up there and supercharge snowfall so that it nucleates and causes more snow to fall. For a while there, we weren't sure that this was actually working, but we were doing it anyway. And we finally discovered that maybe it was working, and that's pretty cool. Yeah, I'm going to talk about this way more on the air lesson. And another thing that's in the air is maggots, baby maggots. So this is a really neat experiment I love, where back in the 1600s, I believe, this guy, his name was Francesco Redi. He was an Italian scientist, and people back then thought that there was something called spontaneous generation. Basically, animals, organisms, mice, frogs would just pop out of nowhere. We had no idea that there was actually something that needed to come before that, and that was like the egg. And so here's an experiment where he took a piece of meat, put it in a jar, put a cap on it, and then he had an open jar. And in the open jar, he saw maggots start to form because the flies were able to go down and put their eggs in the meat. But in the flask where it was sealed, there were no maggots. And flies are adult maggots, yeah. It's a larval stage is the maggot, and it develops into a fly. Insects are really cool because they have two distinct life phases. So are frogs. But yeah, this is like the change element of this curriculum, is that you can change. You can totally reinvent yourself just like the insects. And you can morph, which is kind of cool. Water. So if we dive into water, I love this graphic because it shows that even though the world is covered in water, we are the blue planet. If you look at all of the water in, on, and above the earth, the liquid fresh water is just this tiny little drop, which is sort of crazy. So all water on, in, or above the earth would be there. This is the little liquid fresh water, and then fresh water in lakes and rivers is even smaller than that. So in the water module, we'll dive into what it means to keep our water clean, because that is a basic human right to be able to have fresh water. And right now we're doing a terrifically amazing job of destroying our waterways and diverting them and drying them up. And so there's lots of villages that don't have water and they are collapsing. And so anyway, so we'll talk lots about issues of keeping our water clean in that lesson. Water is also the universal solvent, and that's what it looks like. And if there was a world without water, the only thing that probably would survive is this thing called a tardigrade or a water bear, which has been sent out into space, and it forms a little cyst, basically, like it goes into a dormant state where it doesn't need any water. But isn't that kind of fun? It's called a tardigrade or a water bear. Yeah, that's a water bear. I'm gonna skip this. We're gonna talk about the Great Pacific Garbage Patch in the water section, which is basically all the garbage that ends up in the ocean, ends up in a big plot of plastic, which some people have called a real landmass, even though it's floating, but it's the size of Texas. And it's caught up in something called a gyre, which is a area of, it's like where the currents form to collect all this trash. Avery, go ahead if you turn your thing on. So talking about a cool example of science is cleaning up plastics from the ocean. Fionn Ferreira. Oh, neat. You made it glow like the universe. I love it. So Fionn, he developed a way of actually clearing out microplastics from the water using iron magnets, basically. And I want to leave you with this. These are two super inspiring people about your age. Anybody know who they are?
Malala Yousafzai and Greta Thunberg.
Yeah, totally. And so they recently met up at Oxford, which made me super happy. But these are two real big game changers. They care a lot about the world and they care a lot about making it better. And Greta, yeah, the how dare you meme, totally. And so this makes me emotional thinking about it. But Greta Thunberg, even though she has Asperger's and OCD and she cares dramatically about the planet, and she has been able to form massive movements where she gets lots of people to strike on Friday from school. So they don't go to school on Friday and they say, hey, look, you guys, we need to change the rules. The rules have to change. Everything needs to change, and it has to start today. And so she's really asking for a large system change in a lot of the ways that we operate, so that we can have a really awesome future for all of you who are growing up and inheriting sort of a lot of problems right now. And Malala, what she's saying here, when the whole world becomes silent, each voice becomes powerful. So when a lot of issues are happening and no one's speaking up about it, that should encourage you to use your voice to make a difference in the world. And you do make a difference in this world where there's 7 billion people and growing. These are all the different people. We might not be alone. There might be life on other planets. This is all some random things. Lots of different science stuff. But out there in the universe, there might be other life, which is kind of a fun thing to think about as well. So we might not be alone here. There might be life out in other planets, which I love talking about. So this is back to the element of the universe, or the heavens. We're going to conclude there. That was a lot to go through, but I hope you got a sense of what it would look like if you continue to take lessons from me. We'll talk about everything from science to spirituality, myths to facts, and kind of tie it all together in a way where you feel confident that you can do something to learn some science, learn ways to make a difference in your community, and feel empowered and supported to do so. So I will send a follow-up email with the next lesson that'll be happening. And the website that I post a lot of lessons on, you guys can all, if you're interested, you can go sign up there and see some different lessons that I have on there and talk to different classmates. So if you want to write this down, Avery, if you want to type your email in, I'll make sure to get it, but I will send you all a follow-up email. So it's called thewonderment.com, and if you go to channels/science at home, thanks, Avery. Oh, wait, I got your email. Totally. Thank you. But here's my page. Here's a fun lesson on penguins, which has some engineering projects to it. You can write about, we just learned about the ocean with my 9th grade bio students. I like to visit the desert and think about crazy things, like what kind of sci-fi stories can happen out there. So I collected.
What's your most recent one?
The most recent one will be posted about how to experiment. This is my most recent one. I'm really obsessed with water testing right now. So I went out and I tested the water, took some notes. You can see here. I actually found out that the water we were using from the river was burning the plants. And that was because there was high nitrates in there. So there's expert interviews. This is a watershed protector, one of my friends, who tells us all about water. And then these are a couple students that test everything from pH. This is a coworker that I work with, and she tested dissolved oxygen. So if you were to go out and you wanted to do this lesson and get a water badge and post on here, then I could, wait, not this thing. You could gain a badge that would say that you completed this element. And as you complete more and more elements, you have access to more and more lessons, which is kind of the cool thing.
Can you please copy paste that link into the chat?
Yes, I can. Thank you for that. Here it is. So you can create a little avatar. So mine is an octopus with a unicorn head, which I think is pretty fitting. But you can do all sorts of really cool things. Oh, and thanks, David, for the suggestion. What if? Answers a bunch of cool science what if questions. I love that. I'm going to go check that out. Okay, so awesome. Thank you guys so much for being in this lesson. It was fun to chat with you and get to know more about what is at the center of your universe and how you think about the world. And I hope you join me for the next lesson.
Can you post the link in the chat?
Oh, I'm so smart. Sorry, I keep privately talking to Smriti instead of putting it here. Oh, and next time, if you come to my next lesson, I can't believe this. So I actually have a snake and her name is Miss Kitty. And so if you come to the next lesson, you can meet my snake.
Yeah, I'm coming to the next lesson for sure.
Yeah, okay, awesome.
I
So
want a
good.
snake. I want a snake, but my mom is severely afraid of snakes, mice.
Oh.
I don't know anything else but snake and mice, and I want a snake because I know I know how to tell if they're like poisonous and non-poisonous, and I really want a snake. And my mom, I said, I know that I want a snake, and I already know what you're gonna say. She said, what? And I said, not in my house. And she said, yes, not in my house. Maybe when you grow up and move into your own house, you can have a snake.
There you go. When you grow up, that's something to look forward to. I got my snake 7 years ago, so I was in college at the time. And she's been with me. She moved all the way across the country with me. She was like on my dashboard sunbathing while I drove through Montana from Wisconsin to Utah. So I highly encourage you to get a snake. I think they're the best pets. They're so fun.
Definitely.
Okay. Bye, everybody. It was so fun to get to know you. Bye, Avery. Bye, Morgan.
Bye.
Bye,
I
Danielle,
probably-
David.
I'm probably gonna ask my mom, and it's science, so she'll definitely let me come next time if I
Cool.
want to. I definitely do want to.
Awesome. Well, I'm so excited to be on the journey with you, learning about the world.
I just
Bye.
registered to your website.
Yeah, you should. Oh, cool. Awesome. I can't wait to see you on there. Cool. Okay, I'm gonna end it pretty soon here. Bye, Morgan. Bye, Smriti. Bye, Patrick. Bye, Daniel. Cool. Bye, Morgan. Oh, ferrets are awesome. Yeah.